Today we will be learning about how to generate electrical energy by using thermal power stations. What is the necessity of electrical energy? For modern development of any country, electricity or electrical energy plays vital role. Without electrical energy today, a person cannot work fastly, a machine cannot run, a industry cannot function smoothly, or a train cannot move, a vehicle cannot run. So these are very much important to use the electricity or electrical energy. A person development or in a country economy depends so much on electrical energy. If a country is generating more electrical energy or electricity, that country develops like anything. Compared to our country, the European countries, they are generating more electrical energy, therefore their development is also very much faster. And today's civilization also depends more on utility of electrical energy. This electrical energy can be generated in many methods like hydroelectric power stations, diesel power stations, nuclear power stations and thermal power stations. Out of all these power stations, thermal power stations plays very important role to generate the electrical energy, because in our India we have plenty of coal mines or coal belts. Therefore, if we can utilize these coals to generate electrical energy, many years we can produce the electricity. And not only that, these thermal power stations works on base load. What is mean by base load? Electrical energy can be supplied to consumers throughout year without disturbing, because the raw material availability will be plenty in India. If you compare other electrical power stations, they depends on the nature. So therefore, these thermal power stations need not depend on nature. So thermal power stations. Today we will be discussing how the thermal power stations functions. What is meant by a thermal power station? We will wonder in our childhood, what is this? By using the coal, how we can generate the electricity? Yes, it is true. We can generate electricity by using the coal also. You take a small vessel, put a water inside and you go on heat it by keeping on heater. At one stage entire water will be boiled, but you go on heat it, the water which is boiled is converted into the steam. Therefore, the power stations works on steam. The pot or vessel is nothing but a boiler here. So in the boiler plenty of water is filled. This water is converted by using the heat energy. So a thermal power station basically can be defined like this. Thermal power stations, a generating station which converts heat energy of coal combustion into electrical energy. So a thermal power station can be defined. Heat energy of coal combustion can be converted into electrical energy. So heat energy, how we get the heat energy? By burning the coal. The coal are classified into different forms. Example, the types of fuels used in thermal power station: peat, lignite, bituminous coal, anthracite. There are four types of coals which are used in thermal power station. Peat and lignite, these two are very raw materials. The coal can be get from the underground mines. So, the very first stage of the coal is called peat or lignite. The coal should have less moisture content for good burning, and the coal will have an oxygen, nitrogen, sulfur, etc. The coal should have high calorific value so that quick burning will be there and entire coal can be combustion, and the carbon content must be more and the ash content should be very less. So, basically the coal should have less moisture content, more carbon content, less ash content, high calorific value for complete utility of coal. So, therefore, out of peat, lignite, bituminous coal, anthracite, mostly bituminous coal will be used in all thermal power stations. Why only bituminous coal? Because it has got less ash content, less moisture content, high calorific value. Even anthracite also has got good properties compared to bituminous coal, but it is a very hard. So, making into small pieces, it will be very costly by using the anthracite because it is a hard coal. Therefore, mostly bituminous coal will be used in power stations. Let us see with this picture how a coal will be converted into electrical energy. Energy transformation. Basically, there are three important mountings in a thermal power station. This circle is called a boiler. This is called a turbine. This block is called a generator. The boiler is nothing but in a vessel filled with water. This is filled with water. The boiler down part, it will be divided into two parts. Upper part is filled with water. The lower part is called furnace, where the coal will be fed into the furnace. So, the incoming material or the input to the boiler is coal. The coal is fed under the bottom. So, that is called furnace area, where the coal will be burnt. Once the coal is burned, lot of heat energy will be coming out. So, the water which is filled in the boiler is converted into steam due to the heat. That steam is in wet condition, and that steam also will be high pressure will be created inside the boiler. That high pressure steam is fed to the turbine. We know the definition of turbine. The turbine converts heat energy or steam energy into mechanical energy. So, therefore, the high pressure steam is fed to the turbine, where turbine has got different blades. So, due to the high pressure of the steam, the turbine blade starts rotating it. Therefore, it converts into mechanical energy. This mechanical energy is transferred to the generator through some coupling system. So, therefore, the generator starts rotating it. We know the Faraday's law of magnetic induction. By rotation of generator, that is armature, the electrical energy is developed. Therefore, the purpose of generator is to convert mechanical energy into electrical energy. This electrical energy is transferred to the bus bar. Bus bar is nothing but a different feeders. So, through the different feeders, it will be connected to the different switch yards. So, in this, the chemical energy boiler, chemical energy converts to heat energy. In turbine, heat energy is converted into mechanical energy, and in generator, mechanical energy is converted into the electrical energy. This is the simple explanation for a thermal power station. So, basically a coal is fed to the boiler, where in the boiler the heat energy is converted into the steam energy. This steam energy is fed to the turbine, where the turbine converts the steam energy into heat energy, mechanical energy, and this mechanical energy is again fed to the generator, where in the generator the mechanical energy is converted into electrical energy. This electrical energy is connected to different switch yards. From the different switch yards it can be transmitted to different areas. So let us look at the schematic diagram of an entire thermal power station through this diagram. The working of a thermal power station. This is a boiler. It is in the heart of the thermal power station, and to this boiler from one side the coal is put into this boiler through various stages. This is coal storage, this is coal handling plant. From this the coal is fed to the boiler. After burning, the coal is converted to the ash. The ash will be removed through the ash handling plant to the ash storage, and in the boiler the water is converted into the steam. That steam is fed to the superheater, where in the superheater the steam is converted into the dry steam with high pressure, that is fed to the turbine. This is the turbine unit. From the turbine the mechanical energy is transferred through this coupling to the generator. From the generator it is transferred to the transformer and bus bar and to different switch yards. And let us look about the turbine. After importing the energy, that is steam energy, into the turbine blades, the pressure will decreases and volume of the steam will increase. This is called condensed steam. It is fed to the condenser, and again that steam is converted into the water through the feed pumps. Again it is reheated, it is fed back to the boiler. This is a schematic diagram of the thermal power station. This figure looks like a very big chart, so I made into 4 stages. Let us see about the first stage of the thermal power station by looking into this picture. So in this I have taken only boiler. This is a boiler filled with water, and from one side the boiler is receiving the coal. The coal is transported from the wagons, that is trains, and dumped into the coal storage. This is the coal storage. Generally the coal storage will be in acres, because each thermal power station, if you are considering a 100 megawatt of power station, requires about 20,000 to 30,000 of coal. Just imagine a 20 to 30,000 of coal to deposit, how much area is required. That is only example for 100 megawatt station, but each thermal power station will have about 10 to 1200 megawatt of generators. So that means 20,000 into 10. So much of coal has to be kept, and this is for one day consumption, but always the coal has to be kept more. Sometimes in coal mines, due to the strikes and so many other problems, the coal may not be receiving. So therefore at least 1 month coal storage has to be kept. So for that a big yard is required, that is kept in coal storage. And from the coal storage the coal is transported to the coal handling plant, where in handling plant the coal will be made into small pieces. The raw material of the coal will be very big lumps. It will be made into small pieces, otherwise while burning the coal may not be burnt completely. Therefore the combustion may not be perfect. So it will be made into small pieces by using the ball mills or some screw conveyors. And this pulverized coal or fine powder is fed into the furnace of the boiler, and where in the furnace the coal will be burnt. After burning, the water will be converted into the steam in the boiler at one stage, and after burning the coal there will be a wastage of coal, that is called ash. The ash will be removed through the ash handling plant to the ash storage, and from there that will be stored in tanks. Now the first stage of the thermal power station is coal fed to the boiler. So after that the ash will be removed through the ash storages, and in the boiler the water is converted into the steam. And let us see the second stage of thermal power station. The second stage. So after getting the steam from the boiler, it will be in wet condition, but with high pressure. That high pressure wet steam is fed to the boiler, this block superheater. This block is called superheater. The purpose of superheater is to remove the moisturized steam and bring into a hot steam or wet dry steam. So the superheater is, it converts the wet steam into dry steam. Why we need only hot steam? Because if we allow the wet steam into the turbine blades, the turbine blades will get rusted up and the efficiency will be decreases. So therefore, to increase the turbine efficiency and to avoid the corrosion of the blades, a dry steam is fed to the turbine blades. So therefore, from the superheated or dry steam is fed to the turbine. In the turbine, the steam energy is converted into mechanical energy. That mechanical energy is transferred to the generator through the coupling system, where in the generator the electrical energy is converted and given to the transformer through the switch and circuit breaker to the bus bar and various switch yards. This is the second stage of the steam transfer or getting the electrical energy. The third stage is, after converting to electrical energy, the steam will be wasted. That means after introducing the steam with high velocity or high pressure into the blades, the turbine will be rotating, it converts the mechanical energy. But the wastage of steam, if we allow into the wastages, it will become a losses. Therefore, instead of wasting this steam, it will be fed to the condenser. From the condenser, again it will be fed back to the boiler to increase the boiler efficiency. So let us see through this picture. This is the boiler, it converts the steam, is fed to the turbine. Now after that, the steam which is coming out and enter into the condenser, this is also called bleeding of the steam. That means the wastage of the steam. It is fed to the condenser, where in the condenser the cold water will be circulating. This is the lake or river, the bottom one is lake or river. The water will be taken through the cold water pump. This is a cold water pump. Through the pump, it is fed to the condenser. Again, it is back to the lake or river. So that means the water will be circulating from the river to the condenser back to the river. So this is the in form of cold in nature. But here the dry hot steam is coming. So this hot steam, after absorbing the coldness from the cold water, it will be converted into the condensed steam. It is in a bubbles form. So this steam again fed back to the boiler through condensate extraction pump, low pressure heater and high pressure heater. So this condensed steam again will be heated with a low pressure heater and further heater with heated with high pressure heater, again fed back to the boiler. So instead of wasting the steam or water, again through the condenser it is fed back to the boiler. It is made into water and fed back to the boiler. So this is the how the again the wasted steam is used into the boiler to increase the overall efficiency of the system. Let us see the bottom one. So here the water from the lake, it will be cold in nature, but after entering into the condenser, the output of the water will be hot water. Can you say why it is a hot water? Because the water is absorbing hot temperature from the condensed steam and it will be converted to hot water. That hot water is again fed into the river, and sometimes if the water is not available in the river, so instead of wasting this water into the river, it is again fed into the cooling tower. The purpose of cooling tower is it takes the hot water, convert into the cooling water. That cooling water again fed into the condenser. Again from the condenser it comes back to the cooling tower. Again it will be cooled down. Again that cooled water will be fed to the condenser. So the water will be coming from the condenser, entering into the cooling tower. From the cooling tower, again it is fed back to the condenser. So like that, the water also should not be wasted in power plants. Let us see the fourth stage. So we have seen the coal is fed to the boiler and whatever the wastage is coming in the form of ash, that will be stored in the ash storage plants, and the water is converted into the steam. That steam is fed to the turbine, from the turbine to the generator, and the wasted steam is coming back to the condenser, and where in the condenser the steam will be condensated, that means made into the water, that again this water will be fed back to the boiler, and in the condenser the water is coming from the river or from the cooling tower. So the fourth stage is, once this water is converted into steam, the lot of flue gases will be coming. We can make use those flue gases also. You can see with this fourth stage figure. This is a fourth stage. This is a boiler. After converting the steam, there will be a flue gases. The flue gases will be passed into the air preheater, and the air preheater is connected to the forced draught fan. What is the purpose of forced draught fan? In a boiler, the underneath there will be a furnace. The coal will be fed into the furnace. For combustion or for quick combustion, it needs the air blowing. So the air should be sucked from the atmosphere through the forced draught. Forced draught means it is nothing but a fan. It will suck the air from the atmosphere, but it is in a cold condition. That cold air will be fed to the air preheater. The purpose of air preheater is to convert this cold air into hot air by taking the temperature from the flue gases, and these flue gases are coming from the boiler. So therefore, from the boiler the flue gases enter into the preheater, and preheater converts the cold air into hot air. That hot air will be fed to the boiler furnace for coal combustion or coal quick burning purpose. So therefore, we are not even wasting the flue gases also. So after the flue gases entering into the preheater, the flue gases will be escaped into the atmosphere through the chimney. So now this is the boiler, flue gases are entering into the air preheater. From the this is the forced draught fan, cold air is entering into the air preheater, where in the air preheater the cold air is converted into the hot air by taking the gases from the temperature from the flue gases and becomes the hot air. That hot air is fed to the boiler for coal burning of the coal, and after taking the temperature from the air, the flue gases will be escaped into the chimney and through the induced draught, and this chimney is top side, it is left open. Therefore, all the flue gases or particles will be left into the atmosphere. From the atmosphere, it will be falling in some some other places. So therefore, these are the various stages how by using the charcoal we can convert into steam energy, and this steam energy can be converted into mechanical energy, and this mechanical energy is how it will convert into electrical energy by using the generator. So this is the brief procedure how a thermal power stations works. So let us see some important points how the thermal working power stations works. The first is coal is transported, crushed into small pieces called pulverization. Coal is burnt in the boiler house. Water is converted into wet steam. Wet steam is superheated in a superheater. Superheated steam is passed through turbine blades. Turbine converts heat energy into mechanical energy. Steam turbine drives the alternator. Alternator converts mechanical energy into electrical energy. This electrical energy is delivered to bus bars and transformers. Let us see the different mountings in a power stations or various equipments located in thermal power stations those we have discussed in a schematic diagram. The first is coal handling unit. The purpose of coal handling unit is to make the big coal into a small pieces by using the ball mills, etc. The second point is boiler. In boiler there are two types of boilers, water tube boiler and fire tube boiler. Water tube boiler means the boiler inner side will be constructed with a tubes and the water will be flowing through the tubes, whereas the flue gases will be passed surrounding the tubes. And in the other type of boiler is fire tube boiler. That means the flue gases will be passing through the tubes and water will be surrounded by the tubes. This is the basic difference between the two types of boilers, that is water tube boiler and fire tube boiler. But more economical is water tube boiler only, because passing the water into the tube and passing the flue gases surrounding the tubes, it is very economical and the life of the boiler tubes will increase. So therefore, mostly the thermal power station they go for Babcock-Wilcox water tube boiler. Next one is superheater. The purpose of superheater is to convert waste stream into high steam. The superheater also, it consists of larger number of tubes and the wet steam is passed through the superheater, and by taking the temperature from the flue gases, the wet steam is converted into the hot steam. And basically the tubes which are mounted in superheater, they are made of chromium and molybdenum to avoid the rust. Then economizer. The purpose of economizer is when the water is coming from the condenser, it will be passed to the economizer, where the economizer will convert this wet water into hot water by taking some of the temperature from the flue gases. This hot water is fed to the boiler so that the boiler efficiency increases. So the purpose of economizer is to convert the cold water into hot water or to reheat the water which is again feeding back to the boiler. The next part is air preheater. Air preheater is to convert the cold air into hot air, and this hot air is fed to the boiler. Economizer and air preheater. And some more points. Condenser. The purpose of condenser is to convert the steam into condensate form. In these two types of condensers will be there, surface condenser and jet condenser. Basically surface condenser will be used in power stations. Then cooling tower. The purpose of cooling tower is to convert the hot water into cold water. This cold water is fed to the condenser. Then turbine, which is the main unit in the power station, which converts the steam energy into mechanical energy. Then alternator, which converts the mechanical energy into electrical energy. Transformer. Basically in power stations the transformers are distribution type of transformer and step down transformer and step up transformer will be used, and the electrical energy will be generated 11 kV or 13.2 kV by using the step up transformer. This 13.2 kV is stepped up into 400 kV, 660 kV, 220 kV according to the need of the customers. Then bus bar. Bus bar is nothing but a distribution box or junction box, where from there it will be connected to different switch yards. Let us see what are the advantages of a thermal power station. The advantages of thermal power stations are: 1. Large amount of power can be generated. Fuel used is quite cheap. Less initial cost. Installed at any place. Requires less space compared to hydropower stations. Requires less space compared to hydropower station. These are the few advantages compared to any other thermal power station. And when there is an advantage, always power station will also have a disadvantage. Can you imagine what is the basic disadvantage of a thermal power station? Lot of pollution will be there. The pollution is due to the ash, the pollution is due to the flue gases, and therefore, due to this pollution, this thermal power station should be located far away places from the thickly populated areas. Let us see the disadvantages. Pollutes the atmosphere and ground due to smoke and fumes, etc. This is the main disadvantage of thermal power stations. The number 2 is running cost is more than hydroelectric power station. Because of various apparatus, the running cost of thermal power stations will be more. Let us see, we have seen the advantage and disadvantage. Let us see some of the points, how to select the thermal power stations, where to select. For each factory, or suppose we want to set up any industry, we have to see some points before selecting the power station or industry. Let us see one by one what are the points we have to see before setting up a thermal power stations. Selection of site for thermal power station. The thermal power station should be nearest to the coal mines. It should be nearest to the coal mines so that the transportation will be avoided. Availability of water. We have seen in the diagram, the condenser needs more water, therefore, it should be nearer to the water point, either lake or tanks, etc. Transportation facilities. The transportation facilities should exist. Cost and type of land. The cost should be very cheap, and at the same time it should not be any loosey soil, it should have a hard soil, so that it should not be the equipment should be mounted very easily. So, cost and type of land. Nearness to load centers. Always the thermal power station should be located as far as possible nearness to load centers, otherwise the transmission system cost increases, and if you are considering for the DC power stations, we cannot step up or step down the voltage, therefore, it should be nearer to the load centers. Distance from populated area. Due to the pollution, it should be located away from the populated area. Labor should be available. The plenty of labor should be available to run the thermal power stations. So, we have seen the selection of site for thermal power station. Let us see what is the efficiency of thermal power stations. So, after taking so much care in thermal power station, that is, we are not wasting the water, we are not wasting the flue gases, we are not wasting the steam. Even then, the good thermal power station or the modern thermal power station, they gives only 30% of the efficiency, balance 70% will be losses only. In this, 50% of the losses occurs only in condenser, balance power losses will be occurring in a superheater or through the tubes, they will be escaped into the atmosphere, economizer, etc. So, the thermal power station efficiency will be not less more than 30%. Efficiency of thermal power stations. Overall efficiency is 29% to 30%. Huge heat loss in the condenser, heat loss into the atmosphere, superheater, turbine, boiler, etc. Let us see efficiency of thermal power stations. The thermal efficiency, there are two types of efficiency. The thermal efficiency is defined as mechanical energy transmitted to the turbine shaft by heat of coal combustion. So, thermal efficiency means the output of the turbine divided by how much coal we have used for combustion. Overall efficiency, the electrical output by heat of coal combustion. So, that means there are two types of efficiency. Up to the turbine, it is the thermal efficiency, that is turbine output divided by coal of combustion. Overall efficiency means the output is electrical energy, input is coal. So, therefore, heat electrical energy output divided by equivalent of heat transmitted as supplied into the boiler, that is coal of combustion. So, this is the formulas for to calculate the thermal efficiency and overall efficiency of a thermal power stations. So, now let us see question answers in a thermal power stations. The first question is, the steam is generated in A, is it in superheater, B, is it in condenser, C, is it in boiler, D, is it in turbine. The steam is generated, it cannot be generated in superheater, cannot be generated in condenser, but it is generated in boiler. So, the correct answer is C, boiler. The second question, mechanical energy is converted into electrical energy by using the following devices: A, boiler, B, condenser, C, turbine, D, generator. Mechanical energy is converted into electrical energy. Mechanical energy is converted into electrical energy. Is it in boiler? Is it in turbine? Is it in generator? Or is it in condenser? It is a generator. Question number 3. Overall efficiency of the thermal power station is, overall efficiency of the thermal power station is above 80%, B less than 30%, C about 50%, D 100%. I told you the overall efficiency of the thermal power station is very less in thermal power stations compared to other power stations, because the last lot of wastages will be there. The main wastage is steam in the condenser, 50% of wastages count for only in condenser. Due to this, always thermal power stations rated for less efficiency, that is less than 30% or about 30%. Therefore, the answer is less than 30%. The question 4 is, superheater tubes are made of copper, aluminum, iron, chromium and molybdenum. The superheater tubes, I told you, always it is made of chromium and molybdenum to withstand the temperature of the flue gases and to avoid the rust, because the inlet of the superheater is wet steam, the outlet is hot steam. So, if you are using any other material, it will be get rusted up. Therefore, mostly molybdenum and chromium type of material is used for construction of tubes in a superheater. The answer is chromium and molybdenum. The last question is, in thermal plants combustion takes place. In thermal plants combustion takes place: A, boiler, B, condenser, C, economizer, D, chimney. In thermal plants the combustion takes place. What is meant by combustion? Burning the coal. We cannot burn the coal either in superheater or condenser or turbine generator. The combustion always takes place in the boiler, that means in the furnace. So, these are the questions. So, let us see briefly about how the thermal power stations works. What is the raw material of thermal power stations? The raw material of thermal power station is coal. Which type of coal will be used? Always bituminous coal. Why only bituminous coal? Because it has got less less moisture content, high carbon content, good calorific value. What is the calorific value? The calorific value of the bituminous coal is about 30,000 kilocalories per kg. What is meant by calorific value? That means if you are using 1 kg of coal, it will give nearly 30,000 kilocalories of heat energy. So, this coal is burned in the furnace. By burning, lot of heat gases will be coming out. So, by taking this heat or temperature from this heat, the water which is there in the boiler is converted into the steam. That steam is in the form of wet. This wet steam is fed to the superheater, converted into the dry steam. That dry steam is fed to the turbine blades, where the turbine blade starts rotating with higher velocities and converts into mechanical energy. This mechanical energy is again fed to the generator, where generator converts mechanical energy into electrical energy as per Faraday's laws. This electrical energy is tapped from the terminals and connected to various switch yards through the transformer, circuit breaker, switches, etc. This is the one part of power flow. Then after importing energy in the turbine, the steam is again fed back to the condenser. From the condenser, it is again fed to the boiler in the form of condensated steam, and this steam again further heated in a economizer and fed to the boiler. This is the one part of circulation of steam, and the other part is after completing the energy, the lot of flue gases will be coming out in the boiler. The flue gases will be escaped into the atmosphere through the air preheater. So, we will see in the next class how the coal will be made into small pieces by using the pulverization, and how the various equipments works in thermal power stations. Thank you.